All right, folks, in today's class, we're going to be adding and subtracting polynomials. And quite a few of the problems are going to look like this. They're going to be geometry-based, where you're going to have to determine the length of the unknown side. And here it is. This is the length that we're trying to find. In these kind of problems, we have to do a mixture of both addition and subtraction, which is why I'm showing you an example that looks like this morning. So in order for us to find the unknown side here, we're given the length of two sides, and we're given the perimeter. So what would I need to do in order to understand how to figure out this side? What do you think? If I'm given the perimeter, perimeter is what? Perimeter is all the sides added together. But I don't know all the sides yet, which means that if I know these two sides, and if I add them together, what do I need to do in order to get this unknown side? I would need to subtract. So let me do this with Algebra Tiles, and then I'll show you how to do it algebraically. And then in class, you are welcome to use either Algebra Tiles or do it algebraically, whatever is most comfortable for you. All right, so first off, let's take a look at this polynomial expression. And what I have is 2x squared. Let's put that right there. 2x squared plus 3x minus 4. So here we go. This is what I've got so far. And then for this polynomial expression, I have x squared, and I have minus 4x, and I have, oh, there's my minus 4. There's my minus 4. And then I have plus 2. So let me move this up here so you can see everything, all the algebra tiles. And what we want to do now is we want to combine terms. We want to add together and group everything that is the same. So here I've got 3x squared. So I'm just going to move these around just a little bit to save a little bit of space. So that's 3x squared. So when I'm adding together, I'm putting together all of my algebra tiles, and I've got 3x squared. Now let's take a look at these x's. Well, this is an x, and this is a negative x. And actually what I need to do here is, just to make sure that we're all on the same page together, I need to name these parts. So this is an x squared. Red is always going to be negative x squared. This is x, and red is negative x. This is 1, and this is negative 1. So here you can see all my different parts. So I've got 3x squared, x and a negative x. X minus x, x minus x, x minus x. Anything minus itself is 0. X minus x is 0. X minus x is 0. X minus x is 0. So I'm left with negative x. Let's talk about the ones. 1 minus 1 is 0. 1 minus 1 is 0. So I'm left with negative 2. So what I have here, when I add together my two legs, is I have 3x squared minus x minus 2. And now what I can do is I can subtract. What I need to do is I need to subtract these two pieces. So let me, first off, we'll keep the 3x squared right here, minus x minus 2, and let me put the 4x squared plus 6x minus 4 here on the paper. So I'm going to do this to conserve space. So I'm going to do x squared, 2x squared, 3x squared, 4x squared. Let me move my paper up a little bit. Then I've got 1, 2, 3, 4, 5, and 6. And then I have negative 1, negative 2, 3, 4, and I need 4 more. 1, 2, 3, and 4. All right. So let me move this up so you can see it. 1, 2, 3, 4, 5, 6, 7, 8. All right. So what I've got here is I've got 1, 2, 3, 4. So 4x squared. 1, 2, 3, 4, 5, 6, 6x minus 8. And here's my minus 8. Now what I need to do now is we're going to subtract. We're going to subtract. And what I'm going to do is I'm going to explain to you what that looks like by writing the other piece right here. So 4x squared plus 6x minus 8. And what we're doing is we're subtracting these two polynomials. But if we're subtracting the polynomials, you see that my negative sign is outside of these parentheses. What that really means is I need to take 4x squared plus 6x minus 8, and I need to distribute this negative to each one of the three terms inside the parentheses. So it's really negative 3x squared plus x plus 2. So what ends up happening is that when I'm subtracting a polynomial, I have to flip all of the signs. So I need to flip all of my signs. Now that I've flipped my signs and that negative has been distributed to each of the terms in my polynomial, now I can collect like terms. X squared minus x squared is 0. X squared minus x squared is 0. X squared minus x squared is 0. I end up with 1. Let me move these two out of the way. 2, 3, 4, 5, 6, 7 x's. And let's collect ones. 1 minus 1 is 0. 1 minus 1 is 0. And I'm left with negative 6. So my final answer for this particular problem is 1x squared plus 7x minus 6. And this is the length of the unknown side. Now let me show you another way to work this problem just using algebra. So here we used Algebra Tiles to give us a physical representation of what's happening. But let's do it algebraically. So the first thing I needed to do is I needed to add these two. I'm sorry, you can't see what I'm pointing at. I needed to add these two sides. So that's 2x squared plus 3x minus 4. And I need to add x squared minus 4x minus 2. And when I do that, I'm sorry, that's a plus 2. Negative 4 plus 2 is minus 2. 3x minus 4x is negative 1x. 3x squared plus x squared is 3x squared, which is exactly what I end up with right here. And now that I'm subtracting these, again, I need to distribute that negative sign to each one of the three terms. Each one of the three terms. Negative times a positive is negative. Negative times a negative is positive. Negative times a negative is positive. Now I can subtract each one of these. Negative 8 plus 2 is negative 6. 6x plus x is 7x, and that's positive. 4x squared minus 3x squared is x squared. And you see that the polynomial that I have as an answer using algebra is the exact same as what I got using Algebra Tiles. This is 1x squared because there's one of them here. The coefficient is 1, even though I didn't write it. So 1x squared plus 7x minus 6, 1x squared plus 7x minus 6. The last thing I would like for you to do today is I need you to understand the coefficients and the terms of each one of these pieces. So there is an anchor chart on the board that explains what I'm about to do. I need you to name. Each term is separated by a addition or subtraction sign, and the coefficient is the number of variables that I have. So the quadratic coefficient the quadratic term is the term that has the variable squared. So I'm going to write quadratic term, linear term, constant. We need to also know the quadratic coefficient. How many x squareds do we actually have? Coefficient. And the linear coefficient. So the variable squared is what makes this a quadratic equation or quadratic expression. The quadratic term is 1x squared. The coefficient of the quadratic term, how many x squares are there? There's 1. Now the linear term, now if I cover this up, what does this look like? 7x minus 6. That looks like mx plus b. This is the linear part of the equation. So this is the linear part, the 7x. The linear term is 7x. How many x's do we have? We have 7, and my constant is negative 6. This constant in this quadratic expression also represents the y-intercept. So this is also the y-intercept. And we'll get into that in a couple weeks, but I just want you to kind of know that this part right here is going to be the y-intercept when we get to graph these in a couple weeks. Ladies and gentlemen, this is what your work is going to look like today. I need you to come up with the unknown side or the solution to adding and subtracting polynomials. Then I need you to be able to list and identify each one of the terms and coefficients.